Unlike radiation fog, which is formed when a warm surface cools the air above it, advection fog is formed when warm, moist air passes over an already cold surface. As it does so, the air cools, and when it reaches its dew point, the moisture in the air condenses, forming advection fog. In order for advection fog to disperse, one or more of the conditions for formation needs to change. Either the air must become less moist, a change in the wind direction can reduce the moisture content or change the temperature of the air, or warming up of the cold surface could also cause the fog to disperse. This, however, may be difficult if there is a cloud layer above to block out the sun. Advection fog is notoriously difficult to forecast reliably because the conditions for its formation rely so heavily on the direction of the wind. Even a slight change in wind direction can increase the relative humidity of air over the sea, for example by increasing the fetch or distance travelled over the sea that the air travels before it reaches the colder surface. This means that advection fog can both form and dissipate very quickly indeed. Unlike radiation fog, advection fog can be accompanied by winds of any strength, even gale force. However, the conditions for advection fog are often associated with certain geographic areas and terrain features. Although they look the same, there are several significant differences between advection and radiation fog. For example, radiation fog forms over land only, whereas advection fog can form over the land or sea. Radiation fog requires a warm surface which then cools, whereas advection fog needs a surface which is already cool. Likewise, radiation fog usually dissipates sometime after sunrise once the surface has warmed. Advection fog, however, can persist for days given the right conditions, and radiation fog requires light winds of 1 to 5 knots, whereas advection fog can form with winds of any strength, even as much as gale force.